Hi guys, myself Sudha, studying third year MBBS in AIIMS Nagpur. Let's continue our session on the chapter alcohols, phenols and ethers on which is previous year questions. See, let's continue our session without any delay. Question is identify A and predict the type of reaction. They gave the compound. They gave compound with benzene along with O-methoxy, and at fourth carbon they gave bromine. They're asking predict the type of reaction. First one, whenever this reacts with NaNH2. See, in NaNH2, sodium is positive and NH2 is negative. And see, the hydrogen between these two groups, see, OH3 and Br, these are highly minus I groups. So, highly minus I means they are electron withdrawing groups. Electron withdrawing. So, the hydrogen between first carbon and fourth carbon, that is here. This carbon, it is highly electronegative. So, it has tendency to lose. So, it has tendency to lose. Whenever this hydrogen is lost, it is lost in the form of H plus. And at second carbon, we can see it has negative charge. Whenever it reacts with Na plus and NH2 minus, or what it forms? It forms OCH3 minus and Br and negative at second position. When see after removing bromine is highly electronegative, so it withdraws electron. So we can get positive here and bromine negative, and it forms triple bond. That is 1, 2, forms triple bond. And whenever there is a shift of this bond, see this bond shifts like this, and it produces positive here and negative here. Whenever there is shifting of bond, it leads to the production of positive here, negative, and OCH3. Then what it does produce? It at positive charge we can have NH2 group. So it is OCH3 and NH2 group at where bromine is present initially. So it is known as sign substitution reaction. Sign substitution reaction where bromine is replaced by NH2 at same position. See, we can have bromine, we can have NH2 here also at where negative charge is present, but at this position we can see how bond should shift. See, OCH3 is highly minus I group, so it has tendency to withdraw electrons from these bonds. So shifting of bond is towards OCH3. It does not see in this case if in this case if bond shift like this, then NH2 will be at ortho position, which is more unstable because of hindrance, steric hindrance. So due to minus I effect of OCH3, which it attracts double bond towards that side, attracts double bond. So there will be a shift of double bond towards OCH3. So NH2 will be at meta position. NH2 will be at meta position, which is stable. Which is stable. All because of minus I effect. See, what is mean by minus I effect? The compound or molecule which has tendency to attract, electrons towards themselves. Electron towards themselves is known as minus I effect. It has high tendency. Let's see what is the order of minus I effect. It includes NO2 greater than cyanide greater than CHO greater than COR, COOH greater than COCl greater than CONH2 greater than chlorine, chlorine, bromine, OH and OCH3 and CH2 minus. Next, at last it will be methyl group. This is the order of minus I effect. I suggest you guys please remember this order. This is very important to solve this type of question. This you should remember this order, which is very important. See, which is minus NO2. NO2 is a strong minus I effect. It exhibits minus I effect. See, we also know that OCH3 is also exhibit plus M effect. What is plus M effect? That is mesomeric effect. Mesomeric effect. So, what is mean by plus M? It has tendency to lose electrons. So, it give away electrons. It give away electrons and stabilize the molecule. And it then only stabilize molecules. This is known as OCH3. So OCH3 it has minus I effect and plus M effect. In this question, due to the negative inductive effect of OCH3, it causes shift of bond towards that side. So there will be NH2 at meta position. This is known as sign substitution reaction. That is option C. Next question. The reaction. What they gave, it is 5 carbon. What we can call 5 carbon cyclic compound? It is known as pent cyclic pentane. At first carbon it has hydroxyl group, and when it reacts with NaOH, when it reacts with NaOH, it produces ether. What does it produce? Ether. It produces ether, O minus and Na plus. Whenever it reacts with methyl iodine, and it produces O methyl. They're asking what this type of reaction is known as. See, whenever alkyl halide reacts with RNOA, it produces ether and NaX. See, in this bond, O Na minus. See, O will be negative and Na will be positive. In halide, always halides have high electronegative as compared to any alkyl groups. So it's negative and or positive. So it will be RO minus and Na plus R plus X minus. So what will be there? See, Na is replaced by R and it reacts with an halide. So it will be NaX plus ROR. So it produces ether. Whenever any halide react with RNOA, it produces ether. See, in this reaction, halide should be primary halide. If in case of secondary or tertiary, rather substitution, it undergoes elimination reaction. It undergoes elimination reaction. See, for example, in case of tertiary halide, it is tertiary halide and it reacts with RNOA. Rather it produces ether, it undergoes elimination reaction to produce alkene, and it also produces NaX plus ROH. Rather ether, it produces alkene, because secondary and tertiary, it produces stable carbocation. So it undergo elimination reaction. Elimination reaction. What is mean by elimination reaction? Means removing of groups to produce alkenes or alkanes. For example, to this alkane, whenever we add substance and produce any other group, that is known as addition reaction. Addition reaction. Whenever alkene is treated with Rx, it produces alkyl halide. This is known as addition reaction. So the first option, Williamson's ether synthesis, it is correct because this is alcohol. In the basic media, it has Na plus and OH minus. And in this OH, it has polar bond, so O minus and H plus. So H plus is replaced by Na plus. And after that, they said it reacts with methyl iodide. Methyl iodide, it is a primary halide. So it undergoes and produces ether. So methyl, it is positive and iodine is negative. So Na plus is replaced by methyl group. So it produces ether. So it is option A. Next, option B. What are different alcohol formation reactions? See, we all know whenever alkene treated with water in acidic media, in acidic media, it produces alcohol. See, it is a type of addition reaction. So in addition reaction, it follows anti-Markin, anti-Markin, anti-Markov rule and Markov rule. What is this rule? See, whenever in anti-Markov rule, only HBr follows this rule because HBr in the presence of peroxide, it reacts in the form of free radical. It reacts in the form of free radical. It produces hydrogen free radical and bromine free radical. And bromine free radical, it attaches to, it reacts with alkene. So it follows anti-Markov rule. Any free radicals, it reacts with alkene in the form of anti-Markov rule. Anti-Markov rule. What is this rule? It in this rule where H plus substitutes in a carbon which has less substituted groups. Less substituted groups. We all know carbon has four valencies. It can form four bonds. See, the basic is hydrogen. Whenever this hydrogen is replaced by any other group, whenever this hydrogen is replaced by any other group, X or any other group, it is known as substitution. So they are telling H plus, it attaches to the carbon which has less substituted groups, means it has more number of hydrogens. And what is Markov rule? Where H plus is attached to carbon which has more substituted groups, means it has less number of hydrogen. The first production method of alcohol is whenever alkenes react with water in acidic media. Alkenes react with water in acidic media produces alcohol. That is first method. And second method is it is by hydro dehydro hydroboration. Hydroboration. We learnt about this method. See, propene, that is one propene, whenever it reacts with B2H6, what it produces? CH3, CH2, CH2, B, it is CH2, CH2, CH3, and CH2, CH2, CH3. On hydrolysis of this compound, what it produce? It produce alcohol. It produce CH3, CH2, CH2OH plus BOH3 twice. So it produces primary alcohol. This is another method of production of alcohol. Next method is from carbonyl compound. Next method is from carbonyl compound. What is carbonyl compound? That is CHO or CO. We all know on reducing this substance, on reducing it produces alcohol. So what will be the reducing substance? It includes palladium, NaBH4. For example, RCH4. Whenever it reacts with palladium and H2, it produces RCH2OH, which is a primary alcohol. Whenever ketone with reacts with palladium H2 or NaBH4, it produces secondary alcohol. See, these on reduction of carbaldehyde and ketone on reduction, it produces alcohol. This is another method of production. And from COOH, we all know on reduction, it also produces aldehyde and ketone. On further reduction, it produces alcohol. See, the end product of reduction of carbolic acid is alcohol. To produce alcohol from carboxylic acid, we need strong reducing agent, because if we use weak reducing agent, it only converts COOH to CH4 and further it does not convert to alcohol. So we need strong reducing agent, which is LiAH4 in aqueous media. So whenever carboxylic acid undergo reduction in the presence of LiAH4 in aqueous media, it produces primary alcohol. It produces primary alcohol, which is expensive. We all know LiAH4 is expensive. So first we convert carboxylic acid into ester. Carboxylic acid into ester. Then with the help of hydrogen in presence of catalyst, that is palladium, it produces alcohol, RCH2OH. So this is another method of production of alcohol. Next from aldehyde or ketone, aldehyde or ketone in presence of Grignard reagent. We all know what is Grignard reagent, that is RMGX. It undergoes SN1 reaction. It undergoes SN1 reaction. So then it produces ROH. It produces it produces alcohol and MgOH. So from these many reactions we can able to produce alcohol. See, next, what is dehydration reaction? See, what is dehydration reaction? It is removal of water from compound, that is known as dehydration reaction. For example, let's take ethanol. Whenever it reacts in the presence of H2SO4 at 443 kelvins, it produces CH2OH. In this, see, H, 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 C. Removal of this is in this, water is removing. We are removing water from this molecule. OH is removed, then it produces cation here, cation. Then after removal H plus, it produces negative on carbon. So it produces C double bond, H, 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 and H. It produces C2H, C, C2H4 plus H2O. So removal of water from compound is known as dehydration reaction. See, we not only with the help of H2SO4, we can also use H3PO4 or ZnCl2, anhydrous ZnCl2, and alumina. We can use these substances for dehydration. We all know tertiary alcohol. Tertiary alcohol, rather in presence of copper at 573 Kelvin. See, copper is an oxidizing agent. Copper is a oxidizing agent. We all know that in oxidation, alcohol produces aldehyde kin ketone. On further oxidation, it produces COOH. See, rather tertiary alcohol undergo oxidation, it produces alkene. It undergo dehydration reaction. Dehydration reaction. This is option C. So the question is where OH is on replacing OH, it produces ether. So it is Williamson's ether synthesis reaction. So option A is correct. Next question. The reaction. See, what is Williamson continuous etherification reaction? See, we all know that when alcohol reacts with H2SO4 at 443 Kelvin, it undergo dehydration reaction to produce C2H4 plus H2O. Same ethanol, whenever it reacts with H2SO4 at low temperature. At low temperature, it produces ether, that is C2H5O and C2H5O. So it is known as Williamson continuous etherification reaction. See how it is formed. C2H5H5 H H H OH here and one C, C2H5OH. See, where O will be positive pronated alcohol. Then after, when it reacts with further this, which is OH, here produces negative and here it produces positive. So we can see C2H5O, C2H5. So it produces ether on reaction. So on H2SO4 at low temperature, it produces ether, and H2SO4 at 443 Kelvin, it undergo dehydration reaction to produce alkene, that is C2H4. So this is known as Williamson's continuous etherification reaction. And what is Ethard reaction and Gattermann? Ethard reaction and Gattermann-Koch reaction. What is this? See, whenever toluene reacts in the presence of oxidizing agent, that is CrO2Cl2, it produces aldehyde, that is known as Ethard reaction. Same. The production of aldehyde from toluene is known as Ethard reaction. What is Gattermann-Koch? Whenever benzene reacts in the presence of carbon monoxide and AlCl3, it produces aldehyde. This is known as Gattermann-Koch reaction. This is known as Gattermann-Koch reaction. We all saw what is Williamson synthesis. Williamson synthesis, whenever alkyl halide reacts with RNOA. Here RNOA, that is O negative and sodium positive. In alkyl halide, there is X negative and R positive. So there will be production of ether. This is known as Williamson synthesis. Next one. Identify Z in the sequence of reaction. See, what is the reaction they gave? That is 1-butene. That is CH3, CH2, CH, CH2. It has 4 carbons, so it is butane. But it has double bond, so it is butene. Because at first position, so it is 1-butene. 1, 2, 3, 4. It is at first position we have double bond, that's why it is known as 1-butene. So see, when it undergoes reaction with HBr H2O2. See, we all know that this is a kind of addition reaction. Addition reaction. I also said that HBr in the presence of H2O2, it produces free radicals. So it produces free radicals. So how does it react with alkene? We all know that whenever halide reacts, it should react in this manner, but which is wrong. It is according to Markov rules. It is according to Markov rule. But HBr in the presence of H2O2, it produces free radicals. So the addition will be according to anti-Markov rule. So C double bond at first position. See, it has 1 hydrogen and it has 2 hydrogen. We all know that H free radical and Br free radical, where H should react at a place which has less hydrogen. So it reacts at second position. So it forms C, H and H. And at first position, it replaces with Br. H, Br. So what does it form? CH3, CH2, 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 Br. This is the reaction whenever HBr reacts in the presence of H2O2. See, HI or HCl in presence of H2O2, this addition will be according to Markov rule, because it does not produce free radicals. See, it does not produce free radicals. HI in presence of H2O2, it produces I2. See, so HCl also in presence of H2O2, it produces Cl2. So it does not produce free radicals. So it according to Markov rule only, addition takes place. Only HBr follows different rule because of this free radical production. They're asking after this what it takes place when it reacts with C2H5ONA. When it reacts with C2H5ONA, that is CBr. Whenever it reacts with C2H5ONA. Here C2H5ONA, it is negative and it is positive. We all know that whenever primary halide reacts with R and RONA, see what does it form? RO minus and Na plus. Here R positive and X will be negative. It forms ether. So what does it form? It replaces bromine and C2H5 comes here. So it will be CH3, CH2, CH2, COC2H5 plus sodium bromide. See, whenever primary halide reacts with RONA, it produces ether. This is Williamson ether synthesis method. See, what are the key concepts in this? Where HBr in the presence of peroxide, it undergoes addition reaction, and in the form with whenever HBr reacts in the presence of hydrogen peroxide. it produces free radicals. So addition will be according to anti-Markovnikov rule. It will be according to anti-Markovnikov rule. Hi or HCl in presence of H2O2, it does not produce free radicals. So it will be according to Markovnikov rule. And whenever primary halide react with RNOA, it produces ether. No secondary or tertiary halide doesn't give this reaction because we all know secondary or tertiary halide rather substitution rather substitution it undergo elimination. So it does not produce ether whenever it reacts with whenever it reacts with RONA. So option will be option A, that is CH3 and 3 times of CH2 and OC2H5. So it is wrong. And option B will be there are two CH3s and CH2 OC2H5. It is wrong. It will be CH3, CH2 twice and OC2H5. So option C also wrong. Option D, that is CH3, CH2, CH, OC2H5. So it will be option A. Next question. Among the following ether, which one of the following produces methyl alcohol on treatment with concentrated HI? Which one produces ether on treatment with concentrated HI? See how ether reaction is formed. ROR, whenever it reacts with HI or HX, it first there will be formation of ROH and RX will be formed. On further reaction of ROH, it produces RX and H2O. So there will be the production of two alkyl halides in case of whenever ether reacts with any alkyl halide first. In first reaction, it produces alcohol along with alkyl halide, and in second reaction, when alcohol on further reduction with HI, it produces alkyl halide plus water. In option A, that is C, 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 O, C. This is O negative and C positive. In option B, that is C, O, C, C, C. It will be O negative and C positive. Here it is secondary carbocation. It is secondary carbocation and it is tertiary carbocation. C, C. Option 3 will be C, O, C, C and C. Branching is seen at third carbon. Branching is seen at first, second, third. So it is at second carbon. So on removal, that is O negative and positive of carbon, it will be primary carbocation. And D, that is CH3, CH2, 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 O, CH3, C. HA or HBr. They are very big molecules. Very big molecules. The size of iodine and bromine is very much big. Is very big. So we can see steric hindrance. We can see steric hindrance in case of HI. So it will attach to lower carbon. It will attach to lower carbon. So whenever, see, first option, whenever it breaks, it produces C positive and O C minus. So halide should be attached here, but it is not correct because halide has this iodine has steric hindrance. Steric hindrance. So what does it form? C H plus and I minus. So it does not attaches here. The compound will not be stable according to steric hindrance. According to steric hindrance. In second, whenever it forms, that is CH3OH and C, C, C and iodine. It also has steric hindrance. Then it is CH3OH plus CH3OH, C, 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 C. It is primary iodine. Next is CH3OH along with CH3, CH2, 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 there are three CH2 and iodine. See, it undergoes, this is a type of SN2 reaction. It is a type of SN2 reaction. So, iodine is attached to the carbon which has less steric hindrance and make it more stable. So, according to steric hindrance, so option 1 is incorrect and option 2 it is attached to tertiary carbon. See, this carbon has iodine which is a very big molecule and it is surrounded by three molecules of methyl group. So it also has great steric hindrance to make it less stable. And option C, this is a reverse of option 1. So option C is also incorrect due to steric hindrance. And option D, it has primary carbon which affects less and it is more stable and steric hindrance is also less. Steric hindrance is less because CH3, CH2, CH2 and C. C, it has two hydrogens along with iodine and one CH2 group. So that is less steric hindrance. So option D is correct. Next one. They're asking when CH3, CH2, CH2, CH3, CH2, CH, CH2O, CH2, CH3 reacts with HI. They're asking when ether reacts with alkyl halides. When ether reacts with alkyl halides, what does it form? Now only we saw that whenever alkyl ether reacts with alkyl halides, that is alkyl halides, that is RX, for in first reaction it produces ROH plus RX. In second reaction it produces ROH plus RX, it produces RH plus H2O. This is the reaction whenever alkyl halides reacts with ether. So first will be CH3, CH, CH2, O minus, CH2, CH3. So see, it has positive, it has positive. Which positive is more stable according to minus I effect? See, it has negative tendency grade. So if it is positive here, these are electron releasing groups which makes more stable this carbocation comparatively to this. So it will be CH3, CH, CH2 plus, CH2 plus, CH2 plus and CH2, it will be, and C2H5 O minus. So whenever it reacts with alkyl halide, that is HI, alkyl halide, that is HI, it produces H plus and I minus. What does it produce? CH3, CH, that is here CH3 and CH2I plus C2H5OH. See, the major concept here is on which side the carbon will get positive. So whenever the positive charge attached to the plus 5 groups, these are plus 5 groups. We all know C2H5 CH3, CH3 tries. These are plus I groups. What is meant by plus I? Plus I means whenever the compound has tendency, it has tendency to lose electrons or to give away electrons. Give away electron is known as positive inductive effect. So it exhibits positive inductive effect. It has more plus side as compared to this side. So here the positive charge on this carbon is more stable. So it is where iodine is attached, and this is where C2H4OH. It is option D. Next question. Where ethanol and dimethyl ether form a pair of functional isomers, and the boiling point of ethanol is higher than that of dimethyl ether. This is due to the presence of C2H5OH and dimethyl ether. Dimethyl ether means they are CH3OCH3. See, the number of carbons. These are what is meant by functional isomers. Functional isomer. It has same number of same number of same number of molecules and formula and exhibit different physical properties, physical and chemical properties. See, it has two carbons and six hydrogens and one oxygen, and it also has two carbons, six hydrogen and one oxygen. See, these two have same number of carbon along with same number of hydrogen, also have same number of oxygen. So it is functional isomer because one is alcohol, one is ether. So they are asking why they both have different boiling points. See, the structure of C2H5OH is, it is here the carbon is sp3 hybridization. So it has tetrahedral groups. It undergoes sp3 hybridization. In sp3 hybridization, the shape is tetrahedral. Tetrahedral. See, in this is tetrahedral. In case of OCH3, this is CH3. This is OCH3. See, here also the carbon is sp3, but the bond angle, they are also, what is the normal shape in case of sp3? That is tetrahedral. The angle should be, that is 109 degrees 28. So the angle should be that much, but here due to presence of two lone pairs on oxygen, the bond angle is reduced. Bond angle is reduced. So this bond angle is reduced due to, this is reduced due to repulsions on lone pair of oxygen. Because of this, bond angle is reduced. And another property exhibited by C2H5OH is, see, it has OH. See, whenever it reacts with another C2H5OH, CHHCHOH. See, this oxygen has lone pairs and it reacts with hydrogen. So this oxygen also reacts with another compound, hydrogen. So this is, it contains intermolecular hydrogen bonding. Intermolecular hydrogen bonding between C2H5, which is absent in case of C2H5. CH3OCH3 does not have hydrogen bonding. So what is meant by boiling point? What is meant by boiling point? The point at which the liquid starts to vaporize. Means when the temperature is that point where liquid is converted into vapor form, that is known as boiling point. The boiling point of water is 100 degrees centigrade. At 100 degrees, it starts to form vapor. At 100 degrees, it starts to form vapor. See, due to presence of hydrogen bonding, the boiling point, due to presence of hydrogen bonding, the boiling point of C2H5OH is increased. C2H5OH is increased because when our molecule is free, it evaporates fastly. So we all know that alcohols are volatile substance. Alcohols are volatile. It means they can easily evaporate. Easily evaporate. So, but C2H5, due to hydrogen bonding, the boiling point is increased as compared to CH3OCH3. Option A, hydrogen bonding in ethanol, that is correct. Option B, hydrogen bonding in dimethyl ether. We all know in dimethyl ether it does not contain hydrogen bonding. So option B is incorrect. Option C, CH3 group in ethanol. C does not say they both have same number of alcohol, same number of carbons and same number of oxygen, same number of hydrogen. C. Molecular weight is same. Molecular weight is same. Formula is same. Formula is same. They exhibit different properties. They exhibit different properties. See, the presence of CH3 group doesn't make any difference in this because they both have same number of groups. So option A is correct. Next question. Whenever formaldehyde whenever formaldehyde bond present with formaldehyde on heating with periodic acid. See, they're asking CH2OH and CH2OH. CH2 and OH on heating with periodic acid. Periodic acid. What is periodic acid? That is HiO4. This is HiO4. Whenever presence of this, what does it form? It breaks this bond. It breaks this bond. Periodic acid breaks the bond between carbon molecule. Carbon molecule. So it breaks the bond. It produces CH2OH twice. CH2OH twice plus CH2OH twice. See, this carbon has H, OH and OH. See, it has more steric hindrance. Two OH groups on same carbon. See, two OH groups produces more steric hindrance. So what does it cause? CH, H. So on release of water, it produces H, C double bond O, H. It produces formaldehyde. So it has two CH2 groups. So what does it produce? Two formaldehyde. See, whenever CH2OH twice, CH2OH twice reacts with periodic acid, what does it do? What does it takes place? Breaking of bond between two carbon molecules. It produces two CH2OH taken twice. Due to steric hindrance, there will be release of two water molecules and it produces two formaldehyde. So it will be option C. It is option C. We all know that H2SO4, H3PO4, whenever it reacts with alcohol, it undergo dehydration. See, whenever it undergo dehydration. See, primary alcohol, it requires more temperature and more concentration of H2SO4, more temperature and more concentration of H2SO4 to undergo dehydration reaction. Whereas secondary alcohol to undergo dehydration reaction, it requires only 85% of H3PO4 because concentration is required less, because in case of secondary alcohol there is stable carbocation is formed, so easily we can easily remove. See, for example, C, OH and C. It whenever H is added to this, what it forms protonated alcohol. It forms OH plus. So H plus. Whenever we remove this, it forms secondary carbocation. So C. So rather than this molecule, it has stable secondary carbocation. Stable secondary carbocation. In case of tertiary, C, OH, it causes pronation. It forms pronated alcohol. After removing this group, what does it form? Tertiary carbocation. See, tertiary carbocation is more stable than secondary, is more stable than primary. That's why removal of H2O from tertiary alcohol is more easier than secondary, is more easier than primary. So the concentration of H2SO4 is decreases from primary to tertiary alcohol. Let's see some reactions of alcohol. Whenever alcohol reacts with carboxylic acid, what does it form? It produces ester, that is ROCOR dash. Whenever alcohol reacts with carbonic anhydrase, that is COO twice, that is COO twice R dash, what does it produce? ROCOR along with carboxylic acid. It produces ester along with carboxylic acid. We all know whenever carboxylic acid along with ester, it produces carbonic anhydride. It produces carbonic anhydride because whenever we add water to this reaction, it produces carboxylic or ester. Whenever we remove water, it produces carbonic anhydride. See, let's see some reactions of phenol. See, in phenol, whenever it reacts with oxidizing agent, that is sodium dichromate in the presence of H2SO4, that is acidic media, it produces dibenzoquinone, that is double bond O. This is the oxidation reaction of phenol. We all know whenever primary alcohol, that is whenever aromatic alcohol undergo oxidation, it produces dibenzoquinone, benzodiquinone. Whenever alkyl alcohol produces undergo oxidation reaction to produce aldehyde or ketone. On further oxidation, it produces carboxylic acid. For production of alcohol to carboxylic acid, we need strong oxidizing agent, that is potassium dichromate or potassium permanganate. Or for the production of alcohol to aldehyde or ketone includes Cr2O3, chromium oxide, ZnO, Cr2O3. For production of carboxylic acid into alcohol, we need strong reducing agent, that is LiAlH4. But for production of alcohol from aldehyde to from aldehyde to alcohol, from ketone to alcohol, we need hydrogen or palladium. This is the formation of alcohol from different groups. We all know oxidizing power of carboxylic acid is greater than aldehyde is greater than ketone is greater than alcohol. This is the oxidizing power. Oxidizing power. We all know that whenever phenol, after removing H plus, it produces phenoxide ion. So why the action of phenol is only at ortho and para? See, whenever this is distributed here, this bond is shifted here. So where there will be double bond O negative here and here. Whenever this bond is shifted, we get positive and negative here. So it will be double bond and it will be positive here. There will be a double bond between them, and here a double bond is formed, double bond O, and positive at para position. Negative at para position. Whenever this bond is shifted here, there will be negative charge here. What does it form? Double bond in between these places in these carbons, and this is double bond O, double bond, and negative here. Whenever this bond is shifted, there will be a positive charge here, negative at oxygen. So it forms double bond here and double bond OC. Positive charge is seen at negative charge is seen at which position? In which position negative charge is seen? That is ortho position and para position. So effect of minus I or plus I groups will be only at ortho and meta groups. Ortho and para groups. Ortho and para groups. See. Whereas resonant effect, irrespective of position, it can show their effect. Irrespective of position, it can show their effect. See. So for example, OCH3 it shows minus I and plus M. So minus I effect will be at ortho and para, but M plus M effect will be at ortho, para, and meta position. So what is in the ortho, para, meta? See, this is OH. The carbon next to the attached hydroxyl group, this is ortho. The subsequent to the ortho is meta. The next subsequent to the meta is para carbon. So this is one. This is one reaction. See, the different enzymes that includes invertase. We all know what is inversion of sugar means. That is sucrose from dextro rotatory to it converts into levorotatory. That is glucose dextrose form plus L fructose. So from plus 62.5 to minus 40. This can be done in the presence of invertase. That's why it is known as this will be inversion of from dextrose to levose. This is known as inversion of sugar. Next, alcohol whenever it is fermented. How alcohol is formed? See, whenever glucose is fermented, whenever glucose is fermented in the presence of zymase enzyme, it produces alcohol and carbon dioxide. This is the production of alcohol from glucose. See. Next one. Next includes different Friedel-Crafts reaction. What is Friedel-Crafts reaction. See, whenever any whenever toluene group is present, whenever toluene or OCH3, methoxy, any group in the presence of AlCl3, that is Friedel-Crafts reagent, that is CH3Cl, in the presence of ACl3, this is Friedel-Crafts reagent. So there will be substitution at ortho and meta positions, at ortho and para position, that is CH3 here. This is will be a minor one, and substitution at para also. See, we all know now, only I discussed due to the resonance effect, due to delocalization of electron, delocalization of electron. The power is only at ortho and para. So it is minor, it is major. Why it is minor? Because of steric hindrance. See, because of steric hindrance, this is minor, and this paramethyl anisole. What is this is whenever CH3 group on benzene is known as toluene. Whenever methoxy group on benzene is known as anisole. Whenever hydroxyl group on benzene is known as phenol. Whenever isopropyl group, that is isopropyl means the that is attachment of benzene group at second carbon of propene. This is known as isopropyl benzene. This is known as cumin. We all know whenever how cumin is produced. See, whenever this oxidation of cumin in presence of air, oxidation of cumin, what it produces? Cumin hydroxide. It produces cumin hydroxide. Whenever it further reacts, whenever cumin is further reacted, it produces acetone. This is a kind of preparation of acetone. How ketones are prepared? Ketones can be prepared from oxidation of alcohol or reduction of carboxylic acid. It is a kind of production of ketone from cumin hydroxide. See, how cumin is prepared? It is prepared from Friedel-Crafts reaction. Along with acetone, it produces phenol. So it is a preparation of phenol and acetone. How phenol and acetone can be separated? By distillation process. Phenol and acetone, it can be separated. It can separated by distillation process because they both have different boiling points. They both have different boiling points. See, what are different oxidizing agents? Different oxidizing agents include potassium permanganate, potassium dichromate, H2SO4, it is a dehydration agent. H3PO4 is a dehydration agent, and alumina is a dehydration agent. Anhydrous ZnCl2 is also a dehydration agent. These are oxidizing agent. These are dehydration agent. Oxidizing agent includes ZnCrO3 and copper at 573 Kelvin. Water reducing agent, hydrogen in the presence of catalyst, that is palladium, and LiAH4 or NaBH4. These are reducing agents. These are oxidizing agents. These are dehydration agents. These are dehydration agents. Please remember these many reagents in alcohol phenol chapter. See, in alcohols, phenol, and chapter, the weightage of this chapter is about 4%. So we only get around 2 to 3 questions. For attempting 2 to 3 questions, you have to be thorough at GOC. Then only you can able to solve 2 to 3 questions. And after that, learning GOC, you have to remember these agents along with alcohols, preparation of alcohols, properties of alcohols, properties, various reactions of alcohol, various reactions, and then how alcohol on oxidation, what does it produce, on reduction, what does it produce. Have to learn everything about alcohol in this manner. Along like this only have to read about phenols, then also ether. See, we have many reagents in alcohol, that is one is Grignard reagent. Grignard reagent, that is RMGS. Next, what is Lucas reagent? Lucas reagent, it is concentrated HNO3 plus ZnCl2, that is anhydrous. Anhydrous ZnCl2. This is Lucas reagent. Lucas reagent. And then there are so many reagents you have to remember. For this, you have to thoroughly revise the chapter. Revise the chapter after this session. You have to revise everything in alcohol, phenols, and ether along with GOC. Then only you can understand very well. That's it from my side. Thank you so much.